Welcome to Networks Professionals.
Welcome to this explainer. Look, if you've been tracking modern tech, you already know that computer vision is basically the invisible architecture driving our entire world right now. From the biometric authentication unlocking the phone in your pocket, all the way to autonomous vehicles navigating complex, chaotic cities, we are entirely reliant on machines that can somehow see. But how exactly do they do it? Well, today, we're going to break the whole thing down.
Seriously, think about this for a second. How does a car actually know it's looking at a human being crossing the street? It's a wildly profound question when you stop and think about it. How does a combination of glass, silicon, and code manage to replicate something as impossibly complex as human sight? We interact with this tech literally every single day, yet the actual mechanics operating underneath the hood, they remain a total mystery to most of us.
Okay, let's dive into this. Here is our roadmap for today. We're going to define exactly what computer vision is, explore some of its real-world superpowers, break down the exact step-by-step mechanics of how computers actually see, dig into the brains behind that vision, and finally, look at the massive industry shift toward edge AI. Let's start right at the top with Section 1. What is computer vision? It's absolutely crucial we set a strong foundational anchor before we get into the weeds. So, computer vision, or CV, is the specific field of AI that enables computers to interpret, analyze, and truly understand visual information from the real world. Basically, it mimics human vision. You can think of it like giving a machine its own digital visual cortex. It is not just passively recording light the way a traditional camera does. Oh no, it actively identifies patterns, recognizes objects, and tracks movement, so it can actually derive meaning from those pixels. All right, now that we've got our definition locked in, let's hit Section 2, real-world superpowers. Let's look at the highly visible ways this is already being applied. And this brilliantly illustrates the sheer scale we are talking about here. It's honestly staggering. On any given day, computer vision is doing everything from object tracking, which is what allows a self-driving car to safely navigate around a pedestrian, to life-saving medical imaging. We're talking about platforms like ADOC analyzing X-rays and MRIs to spot tumors or pneumonia with incredible accuracy. It handles the hypermicro, like mapping precise facial landmarks to unlock your devices, right alongside the macro, like image segmentation. That's where the AI distinguishes the exact pixel boundary between a road and a sidewalk, so a 2-ton vehicle knows exactly where to drive. So we've seen what it can do out in the world. Let's jump to Section 3 and peel back the onion on how computers actually see on a micro level. Let's walk through the linear journey of a single image. Imagine a car's camera rolling up to a stop sign. Step 1 is image acquisition. The camera gathers the raw and usually pretty noisy visual data. Next up is pre-processing. The computer actively cleans up that image, reducing noise and tweaking contrast so it's sharp. Step 3, feature extraction. Deep learning kicks in to break down that visual input, pulling out basic edges, shapes, and textures. It isolates that red octagon. Step 4 is pattern recognition. The model compares those extracted features against a massive, highly trained database. It goes, aha, a red octagon with these specific letters perfectly matches my database for a stop sign. And finally, Step 5, understanding and interpretation. The AI assigns a label and tells the car to hit the brakes. And the wildest part? That entire 5-step process happens in a fraction of a second.
Now for Section 4, the brains behind the vision. Let's get into the specific core technologies that act as the engine for all those steps we just covered.
For a long time, convolutional neural networks, or CNNs for short, have been doing the heavy lifting here. They are fantastic at recognizing edges and textures by meticulously scanning across an image. But there's a new kid on the block, vision transformers, or VITEs. Instead of scanning left to right, VITEs process an image as patches. It's like looking at a giant puzzle and instantly understanding how all the individual pieces form the whole picture at once. Because of that architecture, VITEs are frequently outperforming those traditional CNNs. Now, when we take these powerful models and force them to work in real time, we get algorithms like YOLO. And no, in the computer vision world, we are definitely not talking about the phrase, you only live once. YOLO actually stands for you only look once. Instead of scanning a frame multiple times, YOLO looks at the entire image one single time, predicting what the objects are and exactly where they are simultaneously. That incredible speed is exactly why a self-driving car can instantly react to a squirrel darting out into the road. And you know, it's so vital to point out that these breakthroughs do not happen in a vacuum. This technology is moving at warp speed thanks to massive open source libraries like OpenCV. We're talking about a collaborative ecosystem providing over 2,500 different computer vision algorithms. That open community is constantly sharing tools and pushing the boundaries of what these machines can interpret. Which perfectly cues up our fifth and final section, the shift to Edge AI, and where this whole industry is physically heading next. So, the crucial point is this. Historically, doing computer vision required a ton of internet bandwidth because you had to send heavy video files all the way up to distant servers for cloud-based analysis. Edge AI completely flips that script. Now, the visual data is being processed directly on the device itself, right on your smartphone or the smart camera on your porch. And the takeaway here is massive. Edge processing means zero lag time. And, maybe more importantly, because your visual data never actually leaves your device, it is an absolute game changer for user privacy. We've evolved from clunky, basic image recognition to advanced neural networks processing visual data instantly, right in our pockets. It's been an unbelievable leap. So, I want to leave you with this final thought. As these cameras get smarter and smarter, and as they process data instantly on the edge, without ever relying on the cloud, what exactly will they learn to see next? The gap between human sight and machine sight is closing fast. Thank you so much for joining me for this explainer. Keep learning and keep asking great questions.
Thanks for watching.